Hey guys, read the memo this morning?
From Karen from HR about not eating her labeled foods in the fridge.
Oh yeah, I read that.
No, the memo about the company's new project to design a city on the moon.
I actually worked with Stan on a proposal for that city last week.
How do we even tackle a project so big and so complicated?
Well, Olivia, you start by identifying the problem, and all the engineers at the firm will have to do a lot of background research to specify the requirements for a city like this.
Yes, the environment is so different on the moon, but if we keep going the way we are going here on Earth, there will be no resources left, and we will soon need a city on the moon.
True. After the research comes in, we will need to brainstorm some pretty unique solutions so we don't make the same mistakes on the moon as we did here on Earth.
And then we'll have to use that research to come up with solutions so that we could prototype living accommodations and necessities for survival in an environment completely unlike the one here on Earth.
Yes, I imagine after we test out our prototypes, we'll be having a lot of meetings with all the different engineering disciplines to discuss our results.
And then we'll have to go back to the drawing board and do even more redesigning before we can introduce and implement our final city design solutions. Where's the city going to be located anyway?
Apparently, transportation, mechanical, and geological engineers feel the best location is near the lunar North Pole, in the Peary crater.
Why not the South Pole? Seems like the go-to place in my opinion. Water is key to sustainable life after all. Why risk smaller water reserves and settle in the north? Makes no sense to me.
The water reserves in the south are located in perpetually shaded regions like the crater, but the proposal for this city is at the base of a large crater where there are very likely ample water reserves.
In the north, temperatures are consistent. The city will have access to continuous sunlight from the nearby mountainous peaks that produce solar energy, and an ample water supply in the perpetually shaded areas of the crater. Also, our city will be closer to the mare region than cities in the south, which means that there is less difficult terrain to cover. This makes transportation of mining resources easier and future city expansion more feasible, a necessary trade-off.
Oh, you're already designing transportation?
Yes, Jim. As a transportation engineer, I'm already heavily into the research. We are thinking of making a railroad to and from the mare region for resources and cargo transport, the hyperloop to transport goods and people to outposts for tourism and travel, and a cable car within the city limits to mitigate the dust.
So 3 different modes of transportation? How many people are projected to live in this city?
The intrepid pioneers of this city will be chosen by cultural anthropologists based on their demonstration of certain traits: ability to collaborate and communicate, lack of aggressive tendencies, trustworthiness, self-discipline, adaptability, entrepreneurial spirit, and of course, sense of humor. Their skill specialization will also play a role.
I assume we will need a variety of skills specialists for this to be a viable city, where the citizens are happy, healthy, and safe. It'll be interesting to see how this all goes. I have my doubts on whether this is feasible. Who would have thought that this city, Eclipse's Edge, would turn out to be a model of collaboration and sustainability for the world, and that we would be living here at the base of the Peary crater in living pods with 5,000 people.
A lot of research went into what the living conditions and practicalities had to be for survival on the moon. After many prototypes, tests, and redesigns, we finally settled on a donut-shaped pressurized double-hulled rotating pod trenched in regolith on a maglev track using magnetic bearings. Inside, natural sunlight is simulated.
Eclipseans live, work, and play on pod, a trade-off in terms of space and privacy, but a benefit in terms of shared ideas and resources. The pod has various safety features, which include state-of-the-art healthcare services and fire suppression systems that use drones and ventilation systems to help control and stop fires, both on pod and in microgravity environment without convection.
We also get to wear health monitoring bracelets that help us make important health decisions with the assistance of artificial intelligence. Crime is low in the city because of the Eclipsean shared philosophies, but police still use artificial intelligence and biometrics for monitoring, drones for surveillance, and robots for patrolling in the city and off-pod.
And since we are vegan, we can grow our own food on and off pod in lava tubes using vertical farming and hydroponic technologies. Genetic engineers have altered our plants to higher withstand gravity and higher yield. It is practical and healthy.
We also have laser bees, specially designed aircraft that are equipped with lasers capable of vaporizing asteroids and changing the trajectory away from the moon to protect us.
It is very safe, and I loved having my children go to school on pod in the state-of-the-art designated learning areas. The virtual reality really assisted with the language differences since Eclipseans come from all cultures worldwide.
And off-pod, they had access to a variety of athletic, tourism, and travel opportunities, including the Lunar Observatory.
I'm really proud of the work that solar, mechanical, and electrical engineers put into capturing sunlight on the rim of the Peary and transferring it wirelessly to the pods.
Solar is capturing huge solar farms on the rim, transferred by laser beams of electromagnetic radiation to transfer to stations adjacent to pods. It is then stored in battery walls, while a transmitter coil under the battery walls creates an electromagnetic field. The Devices on pod take energy from this field wirelessly, and boom, the pod is powered.
And who knew that molecular engineers would use tardigrades, microscopic bear creatures, in creating the high-efficiency glass used in solar panels?
Civil engineers have always seen the value in construction aggregate, and lunar regolith is a vital resource in producing this. Mechanical engineers created a remotely operated excavation machine that finds traction in low-gravity environments with little friction, and has an electrodynamic dust shield that can create a weak electric field to propel electrostatically charged regolith.
Structural and manufacturing engineers use a sintering process on the mined regolith heated by microwave technology that is powered by solar. It is then used to produce building materials.
Helium-3 is our city's main economic resource. It is used for rocket fuel for space travel, with the added benefit of its export to Earth, which gives it a green alternative to fossil fuels.
Mechanical, nuclear, and electrical engineers have developed a remote processor that extracts helium-3 by collecting and sifting through regolith, which is heated, releasing helium-3, oxygen, and hydrogen. Oxygen is used to supply breathable air, and hydrogen is used to supply fuel and water.
And speaking of water, this valuable resource is harvested in the permanently shadowed regions using a different mining technique.
The harvested regolith grains are sorted into silicates, metals, and water crystals. The water crystals are taken to the water processing plant so that this valuable resource can be distributed to Eclipseans.
And the great thing about mining regolith and helium-3 is that it is localized to certain areas on the moon to preserve landscape and designated lunar UNESCO World Heritage Sites, like the first footprint on the moon.
Who knew that our city, which started out as an idea many years ago, would become a fully functioning model of sustainable living?
And it required one of the greatest scientific engineering feats of all time.
Yes, and now in our retirement, why don't we go and enjoy a cable car ride through our great city, Eclipse's Edge?